Alright class, welcome to Math 2015, Learning Outcome 8 video. And in Learning Outcome 8 we're going to define variables precisely when we apply them to real-life situations. Okay? So we should take care of how we talk about variables and what variables actually represent in situations. So I'm going to give you several examples. Recall this pattern from an earlier homework. This is figure 1. This is figure 2. This is figure 3. This is figure 4. Okay. So which is better to say for the number of squares in figure X? Should we say that X is equal to 2x minus 1? If you recall that that's how many squares are in each figure. Or the number of squares in figure X is equal to 2x minus 1. Okay. So which is better to say? Figure X equals 2x minus 1, or the number of squares in figure X is 2x minus 1. Okay. So the second way that I've boxed here in green is the more descriptive way and also the more precise way. Okay. So figure X is not 2x minus 1. Let's put a figure in front here. So figure X is not equal to 2x minus 1. The number of squares in figure X is equal to 2x minus 1. Okay, here's another example. Say we have a pattern of blocks where, okay, so we have a pattern of blocks. We built the first few cases of a pattern with blocks. Okay. And figure B, or to know the number of blocks in figure B, has the expression b plus 1 quantity squared plus 2 blocks in it. Okay. Can we say, or should we say, that b equals the number of blocks? That b equals blocks? Kind of gave that away there a little bit. Or is there a more precise way? Okay. Is b equal to blocks? Well, b is a variable. Equal means the same, right? So that equal means the same as. So technically, blocks are not a letter. Blocks are an object. Okay? So there is a more precise way, and what we want to say is that B, so yes, B is equal to the number of blocks. Okay? So variables are numbers. They represent numbers. Okay? Let's take another look at another example. We want to write an equation using the variables s and p. For the following statement. Here's my statement. At this university, there are 6 times as many professors as, oops, get that straight. There's 6 times as many students as professors. At this university, there are 6 times as many students as professors. Okay. So we have that down. We need to use S and P. S for students, or number of students, and P for number of professors. So I want you to go ahead and write an equation where that represents there. So we have use S for number of students and P for number of professors. Okay. So go ahead and pause the video, write your equation, and then compare with what we're going to talk about next. Okay, now that you've written your equation, our question will be, is it 6s equals p or s equals 6p? Okay. So in the reading for the homework, you'll read more about this situation that a researcher found, that students did a lot with 6s equals p. Most people, 70% of people, put 6s equals p. Are we sure about what the answer is? Could it be s equals 6p? Well, in order to figure out, let's do a test. And we'll use some real numbers to help us with our test. So we're going to do test for 6s equals p. Okay. We want to let s and p be some sample numbers. So if let s equal 600, that's the number of students, and when that if there's 6 times as many students as professors, then p is going to equal 100. Okay, so if s is 600, then p is 100. And we can go and put units on there, students here, professors. Okay. Now, we're going to test to see if the relationship of the equation 6s equals p is true. So 6 times the number of students, which is 600, is that equal to the number of professors, which we said was 100? Those two numbers worked for our case. We simplify both sides of the equation. 3600 is equal to 100? No, it is not. Because that's true, 6s equals p doesn't fit the situation. Okay, and it's kind of confusing because but they say that there's 6 times as many students, so you would want to say 6s, right? But it turns out that with this test for s equals 6p, this one is correct. Okay, so it's not intuitive, so that's why many people made that mistake, but we got to look at the situation that models, the mathematics that models this situation. Okay, so again, we're going to let s equals 600 students, p will let equal 100 professors. Okay, so this test will go for 600. Is that equal to 6 times 100? Okay, and looks like that is true. 600 is equal to 600. That checks out. So 6s is equal to 6p fits the situation and is a correct model for it. So going off of this idea, it's another example of being precise with our variables. In the equation, 6 equals, s is equal to 6p. What does the p stand for again? Okay. Give you some choices here. P for professors. B, professor. C, number of professors. D, none of the above. E, more than one of the above. Or F, don't know. There's no way to tell. Okay, so what does P stand for? Go ahead and pause the video. Think about what P would stand for and compare with what our next answer is. Okay, now that you've thought about that for a little bit, remember we want to have our variables stand for quantities and not objects. So quantity is a number of objects, yes. And so the correct answer is C, number of professors. Okay. We don't want the variable to stand for an object. Okay, so the first two are objects. The variable can stand for the number of professors, so part D is part C works, then part D doesn't work because C does work, so it is one of the above. E is more than one of the above, which is not correct, and F is don't know. Well, that's not really an answer. Well, it's helpful. All right. Let's take a look at part 2 here. What does the letter S stand for? Okay, so I'll give you some examples. A, professors. B, students, C, student, D, number of students, E, none of the above, F, more than one of the above, and G, don't know. Okay, so what does the letter S stand for? S stands for one of these. Let's go ahead and pause the video, and you can think about it and think about why you made your choice, and then resume it again. Okay, now that you've done that, let's go ahead and see what we have. Now S stands for nothing to do with professors. S represented the students, right? Or the, not just the students or the student, but the number of students, okay? So that's the answer. Okay. So the number of students, the number of professors. In the homework, we're going to give you some situations, and we want you to write an equation. And you need to define any variables that you use. And this is the key for this learning outcome, is that as you define variables, you need to make sure that you say that they are the number of something. Okay. So the directions on here for this section is to write an equation based off the word problem that we're going to give. We want to define, which means precisely, any variables you use. So here's our first example. A bakery sells pies at $9 each. For $9 each. If the store sold some number on Monday, how much money was made that day? On pie sales. Okay. We're going to write an equation where we're going to find out how much money was sold on pie sales that day. Okay. So go ahead and try this. Pause the video and see if you can think of an equation. And then resume it again when you're done. Okay, so here we have our pie sales. Okay, now that we have thought about this for a little bit, let's go ahead and say, we can name our first variable the amount of money that was made. So we're answering our question. A. Now each pie is $9 each, which is a little redundant, but okay. So we could put 9p there. Okay. Now it says to define any variables that we use. We need to precisely define these. So when they do it, so what we can do is we can go put a comma here where A is the amount of money made on Monday. P is the other variable. P is the number of pies sold on Monday. Okay, so we have our equation and we have our two variables defined. Okay. Next example. Okay, let me go. Yeah, so A equals $9 P times P, and A is the amount of money made on Monday, and P is the number of pies sold on Monday. So you don't want to go too fast through that one at the end here. Okay, so some number of quartets. Okay, so what they mean by quartets, those are composed of 2 violin players, 1 viola player, and 1 cello player. Okay, some number of quartets gathered at a conference. How many players attended the conference? Go ahead and pause the video, try out an equation, and then resume it to see how you did. Okay, so we have 4 players essentially in each quartet. So we want to find a variable that represents the total, 4 players for each quartet times the number of quartets. Okay, where T, so we have our equation, we need to write down what each of the variables mean. T is the total number of attendees okay. Q is the number of quartets. Okay. The equation is T equals 4Q. T is the total number of players or attendees to the conference, and Q is the number of quartets. One last example. The sum of the ages for a group of 20 friends. So the sum of their ages. Was P years. Okay, so we don't know exactly how old they were. So we have P represent that total number of years. What is the average age of the friends? Okay, go ahead and pause the video, see what you can come up with, and then resume it when you're done. Okay, so we want to go back to what average means, and this is kind of a little preview problem for the future. Average means you take the total sum of whatever objects you are investigating and divide it by the total number of objects. So we can say that the average is equal to P divided by 20, because P is the sum of all of their years. Okay. So A is equal to P over 20, where A is the average age, and P is the sum of their ages in years. So A is the average age of each friend. P is the sum of their ages in years. Okay. Notice that we don't have the word number here. A is because ages and sum are already quantities, so they could be directly related to variables. So my equations. Here's what the variables mean. Okay. So let's go over some key takeaways from this lesson. First one, you want to use example numbers to help set up equations to make sure you have them right. Help set up those equations with variables. If you get stuck, or if you want to check your work. Number 2, variables refer to quantities and not objects. For example, B equals number of books, and not just books. Sorry about that. Okay, the last thing. P is equal to the price or cost of a pie and not just the pie itself. Okay, variables refer to quantities and not objects. All right, so let me know if you have any questions on the homework, and yeah, I hope you enjoyed this lesson.